So up to now in the previous videos we have completed up to the biological treatment. So starting from the sewage, when it enters into the sewage treatment plant, it goes to the following processes and each impurity is removed in each of these process. Okay. So now after the biological treatment, the output of the biological treatment is sludge. Okay. Now this sludge is reduced by using sludge thickening and sludge digestion process. So these are the two processes that we have to study in this. So just remember that after the biological treatment of sewage, the output that we get is called as sludge. The output that we get is sludge. Now, so let's see the next topic, that is called as sludge treatment. Sludge treatment. So as I already told you that the sludge is an output of biological treatment. So write down, sludge is produced from PC, that is primary clarifier, and SC, that is secondary clarifier. So this sludge is treated prior to disposal, prior to disposal, and this treatment is called as sludge treatment. Now what does sludge consist of? So this sludge, it consists of two main things. The first thing, we'll call it as the solids part. Okay, so we'll name it as solids. And the second thing which is produced in sludge or which is present in sludge is water. Okay, now these solids are further classified into two categories. So one category is called as volatile solids, and second one is called as non-volatile solids. The amount of water that is present in sludge, we will also call it as moisture content present in sludge. Moisture content present in sludge. And in this we are going to denote the moisture content by P, small p. I hope this much is clear. Now what is the amount of solids and what is the amount of water that is present generally in sludge? So the amount of solids that is present is 1% to 10%, 1% to 10% in sludge, and this is about 91 to 99 percentage present in sludge. Okay, so most of the composition of sludge is water. Now what does this sludge treatment aims? So the aim of sludge treatment is to achieve two things. The first thing is called as volume reduction of sludge, and second one is strength reduction of sludge. Strength reduction of sludge. See, what is the meaning of volume reduction? We have seen here in the composition of sludge that 99 or nearly greater than 90% is water only that is present in sludge. So most of the content is water. So if somehow we are able to reduce this water amount, then what will happen? The amount, or we can say the volume of sludge will get reduced, and this reduction in the volume we are calling it as a volume reduction of sludge. What is the meaning of strength reduction? This sludge is having the solids part, which consists of volatile and non-volatile solids. Okay, so these solids may contain certain chemicals that are having greater concentration, and that concentration we are aiming, or we can say that that concentration is referring to the strength of the sludge. So we have to reduce this strength of the sludge also, and this is generally reduced by doing the anaerobic decomposition process, okay, or we can say anaerobic reactions. So let's write down the next point. Volume and strength reduction. Volume and strength reduction of sludge is achieved by, so it is achieved by what? So these are the following processes. The first process is called as sludge thickening. Sludge thickening. Second process is called as sludge digestion. Sludge digestion. Third process is called as sludge conditioning. Sludge conditioning. And the last process is called as sludge dewatering and drying. Sludge dewatering and drying. So these are the four processes which are employed to reduce the volume and strength of the sludge. So what is the meaning of sludge thickening? So as I have told you that the volume of sludge is reduced by reducing the volume of water. So here in this sludge thickening, we are concentrating the sludge by reducing the moisture content. So write down this point. Concentration of sludge by reducing moisture content. Then the next is sludge digestion. So this sludge digestion aims for the strength reduction. The sludge thickening is doing the volume reduction. This sludge digestion is doing the strength reduction. So it is done by anaerobic decomposition. So anaerobic decomposition for strength reduction. This next process, sludge conditioning, it is also used for the strength reduction, but in this case we are using not anaerobic decomposition, we are using certain methods that comes under the heading of heat treatment and chemical treatment. So we are carrying out heat treatment of sludge and chemical treatment of sludge. And the last one is sludge dewatering and drying. In this case, whatever the remaining moisture is there, that we are removing. So it is used to remove remaining moisture from sludge. So these are the four main processes which are carried out after the biological treatment is done. Okay, so you just pay attention to this chart. So in this chart, as we have seen, the sewage enters through each and of these processes. After the biological treatment, the sewage is converted into sludge and water. Okay, so this sludge is then taken to the sludge treatment plants, where it is followed through the following process. Okay, so these are the following processes, starting with the sludge thickening, in which there is reduction of moisture content. Once the moisture content is reduced, we are going for the anaerobic decomposition, and then if it is required we will go for heat treatment and chemical treatment, that is sludge conditioning. And finally, after doing the first three processes, we'll go to the last process, that is sludge dewatering and drying. After this fourth process, that is sludge dewatering and drying, we'll take the last part of this sludge, and then we will go to the disposal part. Okay, so this disposal is the last part after these four processes. Once these four processes are completed, then it is taken to the disposal part. So where we dispose this, we can either dispose this on land or seas or some in rivers also. Okay, so now coming to the next part, that is mass and volume relation of sludge. Mass and volume relation of sludge. So there are few basic formulas that you should first know. The first one is mass density of any substance. So mass density, it is denoted by rho, and this is equal to mass of that substance divided by volume of the substance. Okay, so if we apply this for mass density of sludge, so we'll get mass of sludge divided by volume of sludge. Mass of sludge divided by volume of sludge. Then the next formula is specific gravity. Specific gravity, it is denoted by S. So specific gravity, it is denoted by, or it is defined as unit weight of any substance divided by unit weight of water. We can also write it as density of any substance divided by density of water. So in this case, if you want to write specific gravity of sludge, then it will be mass density of sludge divided by mass density of water. Mass density of water is a constant value, and that is 1000 kg per meter cube. What is the specific gravity of water? Specific gravity of water is 1. So these are the things that we should know. Now let's come back to the main point of the sludge. So we know that sludge consists of solids and water. That is, water we are calling it as moisture content, and these solids are also further classified into volatile solids and non-volatile solids. So we can write it like this, that sludge consists of solids plus water. Okay, this water is nothing but moisture content. So if you want to write one equation, so we have to write the equation in terms of percentages. Then it will be 100 divided by specific gravity of sludge. 100 divided by specific gravity of sludge is equal to percentage solids divided by specific gravity of solid plus percentage moisture content divided by specific gravity of water. So this is a very important formula from this sludge treatment. Many times in GATE examination and engineering services examination, questions are asked from this formula. Okay, so this is the basic formula. Now as we know, these solids are classified further into volatile solids and non-volatile solids. Okay, so these solids we can also write it as, so in terms of solids, if you want to write it, we can write it as 100 divided by solids, specific gravity of solids, is equal to percentage of, or to make it easier, what we'll do, first we'll write this. Solids are classified into volatile solids plus non-volatile solids. Okay, so if you want to write it in terms of percentage, then we will write it as 100 divided by specific gravity of solids is equal to percentage of volatile solids divided by specific gravity of volatile solids plus percentage of non-volatile solids divided by specific gravity of non-volatile solids. So this is the second equation. Okay, so if in the question volatile and non-volatile solid percentage and specific gravity is given, then initially you have to find it out the specific gravity of solids from the second equation, then use the first equation to find out the specific gravity of sludge. Okay, so these are the important equations for the calculation. Now how to find out the mass or weight or volume of sludge? So for that we will have to go to the next slide. So this thing which I have drawn here, so we'll name it as sludge digester. So what is sludge digester? Sludge digester is an equipment which is used for the digestion of sludge. Okay, we have seen sludge digestion in the second point. Second process is sludge digestion, anaerobic decomposition. So same thing. Now the sewage comes into this sludge digester, and after the digestion certain amount of sewage goes outside. Okay, so let's say the concentration of sewage which is coming inside is C in, and the concentration of the sewage which is going out, it is C out. Now obviously there will be certain amount of sewage which will be digested in this. So what is the concentration of this one? So inside there is C in which is coming, outside C out is going. So if I subtract C in minus C out, will I get this? Yes. So the amount of sludge which is present here, that is C in minus C out. I hope this is clear. Now another point is this sludge. So this sludge consists of how many parts? Two parts, solids and moisture content, that is water. So if this moisture content I am denoting it with P, that is percentage moisture content. So if this is 100, if sludge is 100, water or moisture content is P, what is the percentage of solid? It will be 100 minus P. Then only 100 minus P plus P will be 100. So with this now, we'll write down the following formulas. So the first formula is concentration of dry sludge. Concentration of dry sludge, or we can say concentration of dry solids in sludge. So this will be C in minus C out. Okay. Now if I want to find out the efficiency in this, what is the formula of efficiency of sludge digester or efficiency of anything? It will be whatever is the input minus output, that is C in minus C out divided by input. So C in into 100. Now this C in minus C out, C in minus C out, this we can also write it as, N into C in, that is efficiency into C in. We can write it like this also, where this nu stands for efficiency. So in this formula, instead of C in minus C out, we can write this efficiency into C in. Okay. So this is the first one, concentration of dry solids in sludge. Now what is the total mass of dry solids in sludge? So this is concentration. Now the total mass of dry solids in sludge. So M, it is calculated as Q multiplied by concentration of solids in sludge. What is the concentration of solids in sludge? The above one, that is efficiency into C in. You can also write it as efficient discharge into C in minus C out. Both things are same here. Okay. This Q you have to substitute in MLD. Now, the next formula. What is the mass or weight of sludge produced? So, mass of sludge produced per day. So, this is equal to 100 divided by 100 minus P into M. Next, we will see what is the volume. So, volume of sludge produced per day. Volume of sludge produced per day. This will come in meter cube per day. So, it is mass of volume, mass of sludge produced, mass of sludge produced divided by density of sludge. So from the density formula only we have written it. See, density formula is mass divided by volume. Okay, so this mass we have calculated in the previous one, mass of sludge produced. So if we multiply, or we can say if we want to find out the volume, then how we can write volume? Just shift it here. Volume will be equal to mass divided by density. So same thing we are writing it here, mass divided by mass density. So we can write it as same thing, volume of sludge produced per day is equal to 100 by 100 minus B into M divided by density of sludge, or mass density of sludge to be accurate. So this is the formula for volume of sludge produced per day. This is a very important formula for the calculation of volume of sludge. Now, if there is a very small change in moisture content, then this density of sludge we can write it as, or we can say if we equate it in the sludge digester process, we can even get a relation which will be this volume we will denote with V1 and V2. So we can write it as 100 by 100 minus P into M divided by density of sludge if the volume, or we can say if the moisture content, if there is no change in moisture content, then this mass and density of sludge values will be extremely small. Okay, so this ratio will be nearly equal to 1. So we can get a relationship between volume and moisture content, that volume is equal to 100 divided by 100 minus P, where V is the volume and P is the moisture content. See, what do we mean by volume reduction? Volume reduction means initially the volume was V1 and then the volume has got V2. When will this volume get reduced in case of sludge? We know that sludge consists of solid and water. So if we decrease this water, that is if we decrease the moisture content P, then this volume of sludge will decrease. Correct? So there is an inverse relationship. There is an inverse relationship between volume and moisture content. So let's write it down. From this, if we want to derive a relationship between V1 and V2, we can write it as V1 is equal to 100 by 100 minus Now this will be P1. Similarly, V2 will be equal to 100 by 100 minus P2. 100 minus P2. If we take the ratio of this, we will get V1 by V2 is equal to 100 minus P2 by 100 minus P1. This V1 and V2 is the volume, and P1 and P2 is the, what is P1 and P2 stands for? Moisture content. Okay. So if the moisture content reduces, what will happen? The volume of sludge also will decrease. So this is how we have got this equation, and this equation which I have written it here, you can get the direct problems from this. It is very important one from the sludge digestion or sludge treatment. Okay, so this is an equation for volume reduction. So volume reduction of sludge. So this V1 stands for volume of sludge. So these are the important formulas here from the sludge thickening process. So this, the first thing which we are studying here is a sludge thickening, because we are reducing the moisture content here. Now in the next video we will see the sludge digestion process, that is anaerobic decomposition.